Good evening, sir.
Up to now, only two of you have joined. Just wait for 1 2 minutes more till others are joining. Then we'll start. Okay. So I think we were doing the question answers from NCRT. We can start over with the question answers now. So let's start with question answers. Yeah, Shravan. Shravan.
Sir,
Good evening, sir.
Yeah, good evening. You need to be active during the class. Okay.
Sir.
Be active during the class. Listen to everything what all is taught. Okay. Be attentive.
Okay.
And if you're not getting anything, just ask. That's the only thing we can do. If you ask, then only your doubts, not only your doubts will clarified, other people's doubt will also be.
sir,
Yes.
sir, actually, in the new textbook, all these parts are deleted.
Yeah. So I got
So,
that.
can
That
you
all.
scroll up?
I know that all
Yes,
the
sir.
parts are
Actually, we
not.
have elements, compounds.
Yeah.
So,
So the next chapter is your elements, compounds, and mix. Elements. In this you have just elements and compound. In the next chapter you have atoms and molecules.
sir, actually, in the new textbook, all these parts are deleted of this chapter.
Okay. So just let me get the new book only. Okay, let's get the new ones only. If it's deleted, so we'll get the new one.
All the parts of separation of mixtures are deleted from the new textbook, sir.
Okay. Just 1 minute. It's new PDF. Okay. Okay, these are the two. I think this is the new one. Yes. It
Yes,
has
sir.
only 12 pages. This is the new one. So we in this chapter, see, before ending of this chapter, I would like to just give you review of all the topics that are there in this chapter. Okay. So see what all things are given in this chapter, what all we have to study. Once you open up your book, so the things which we have to study from this. So first of all, you have to study from this book what are pure substances. So can anyone tell me what are pure substances? Yes, what are pure substances? Sherman, what substances are called as pure substances?
It's made up of only one kind of particle substance.
Okay, those made up of only one types of particles.
And they
Made
are
up of,
elements or compounds.
okay, made up of only one type of particles. You don't need to say elements or compounds. Okay,
Okay.
so it can be other than them also, but yes, they have to be pure substances. So pure means made up of only one type of particles. And what are impure substances?
Impure
Yes.
made up of two substance.
Yeah,
Okay.
made up of two or more substances. So those are impure substances. In the impure substances, we generally call them as mixtures. We call them as mixtures. So what are the two types of mixtures that we have studied?
Homogeneous
Sir,
and not heterogeneous.
Yeah, we have studied homogeneous and heterogeneous. So what are homogeneous mixtures? What are homogeneous mixtures? I want you to clear everything from this chapter. Yeah, Harshit.
sir, homogeneous mixtures are the mixtures in which the solute is dissolved completely in the solvent.
What do you mean by completely dissolved?
Uniformly mixed. It's uniformly mixed.
Uniformly. So homogeneous mixtures, they are the mixtures when their solute particles are uniformly mixed with the solvent. So, can you give any example?
So
Sir,
salt
sugar in water.
solution.
Solutions, okay. So your solute particles, they are uniformly mixed with the solvent. So such substances, they are called as homogeneous. Then what are heterogeneous mixtures?
So heterogeneous mixtures are the mixtures in which solute particles are non-uniformly distributed in the solvent.
Okay. So any example of heterogeneous mixtures? Any example of heterogeneous mixtures?
So sugar and salt.
Sugar and salt.
So we can take
Sir, milk. Milk.
chalk powder and water.
Mhm. So I'm writing here sugar and salt. This is an example of homogeneous or heterogeneous.
Heterogeneous.
This is an heterogeneous mixture. Mm. What about salt and water?
Homogeneous.
This is
Homogeneous. Sir.
homogeneous. Okay. Sand and water,
Heterogeneous.
it's heterogeneous. A soap solution, sorry,
Heterogeneous.
so soap solution.
Sir,
Heterogeneous, sir.
Yes,
sir, can
yes,
milk alone be heterogeneous mixture?
yeah, milk is a heterogeneous mixture.
Okay, sir.
Milk is also heterogeneous mixture. Soap solution is also heterogeneous mixture. As the particles, they are not uniformly distributed. So all the true solution and all the colloidal solutions, they are your heterogeneous mixtures. Okay? Colloidal solutions, they appear to be homogeneous, but they are not homogeneous. They are heterogeneous in nature. Okay. Then we had done three types of solutions. That is, we had done solutions or true solutions, then suspensions, and last we had done about the colloids. So we'll write down their properties of suspensions, solutions, and colloids. So it's solutions, and here we are suspensions and colloids. So give me the properties of the solutions. What are the properties that I will write? Yes, anyone? Give me the property of solutions. Which substances will be called as solutions? Why no one is answering?
Homogeneous mixtures are no solutions.
Homogeneous mixture. Okay. So in the, if I'm writing something about the true solution, the very first point I must declare that the true solutions, they are homogeneous in nature. Okay. They are homogeneous. What about suspensions and colloids?
So they are heterogeneous mixtures.
Hmm. So both of them, they are heterogeneous in nature. Heterogeneous
Sir,
colloids are.
actually, sir,
Yes.
sir, what is suspension and what are colloids?
Okay. See, in suspensions, a very simple criteria that you can use. In the case of suspensions, you can see the particles with your naked eyes. Okay. So the next point we write here, the particles are not visible. Particles of solute are not visible. You can't see them. And here, for the suspension, the particles of solute are visible. So for this one, particles of solute are visible. You can see them with your naked eye. So that means they are about a few millimeters, or you can say 10 to the power minus 4 meters. Then, in case of colloids, can you observe the particles?
Sir, no, sir.
No. Here also, particles of solute are not visible.
So means the particles of heterogeneous means colloids are smaller than 1 nanometer,
Not smaller, they are bigger than 1 nanometer.
larger than 1 nanometer or smaller than 1,000 nanometer.
Yes,
Okay,
they are
sir.
bigger than 1 nanometer, but smaller than 1,000 nanometer. Got it? So particles of solute
So
are,
same goes to solutions.
yes,
So the same goes to solutions.
yeah. For the solution, the size of the particles is less than 1 nanometer.
Okay, sir.
The particles of size, they are less than about a nanometer. Okay. What actually means, see, in the case of solutions, the third point we are writing here, particles are small. That means particle size will be approximately of the size of 1 nanometer or less than, even less than. For the heterogeneous, the particle greater than size is greater than 1,000 nanometers. And for the colloids, the size is between 1 nanometer to it's 1,000 nanometer to 1 nanometer. Okay. Any other differences? Yeah, any other differences? Sharman, can you give any other differences between them?
So the Tyndall effect.
Tyndall effect. So which of them shows the Tyndall effect?
Uh, well, suspension shows.
Mhm. Okay, so the next one. So said suspension shows Tyndall effect. And what about these? Solutions and
Colloids
colloids.
doesn't show, solution doesn't show. They
So
do
you are
not
mistaken.
scan.
You are mistaken over here. Everyone pay attention. All the colloids show Tyndall effect. Colloids show Tyndall effect, whereas homogeneous mixtures, they do not show Tyndall effect. So
Okay.
they show Tyndall effect. Colloids, they also show Tyndall effect. And solutions, they don't show. The reason being the particle size is very small to scatter the light. So that is why the solutions do not show Tyndall effect. All the heterogeneous mixtures and homogeneous, that is suspensions, colloids, they show Tyndall effect, whereas solutions, they do not show Tyndall effect. Any other differences if anyone can think of? Just think of the differences. Any other difference?
Sir, I have a doubt in the fourth point. Sir means in whichever solution or suspension or any mixture,
Yeah.
if I want to show the Tyndall effect, the particle size should be more than 1 nanometer.
Not just 1 nanometer. The particle size should be about a size of few hundred nanometers, actually. The particle size should be approximately of the size of 300 nanometers to about greater than this. If you have a size greater than this 300 nanometer, so from 300 nanometer to about a micrometers, then it will show Tyndall. The reason being the wavelength of light. The reason that is there is the wavelength of light. The wavelength of light is about a few nanometers. That's about a 450 nanometer to 750 nanometer. Okay.
So few only means few colloids show the Tyndall effect and few doesn't show.
No, all the colloids show Tyndall effect.
So how so? Because few colloids may be between 100 nanometer to 200 nanometer. Then.
No, so that's why when I'm talking 300, so that means 100. The power is, when you are talking in nanos, so the range we are talking as it should be about 10 to the power 3 nanometers. Okay, so about a few 100 nanometers. If you have the size in 100 nanometers, so yes. Got it?
Okay, sir.
This you are talking of the range. You are given, that means it has to be in thousands nanometers. So it's not just 1,000, it can be 2,000, 3,000, 4,000 nanometers, right? So
Sir,
in colloids, yes,
sir, in the collides, fourth point, what you wrote, sir?
they show Tyndall effect. Tyndall
Okay.
effect means, can anyone tell me what is Tyndall effect?
So the scattering of beam of light due to the particles between the way of the light.
Okay. See, the path of the light becomes visible. This effect is called as Tyndall effect. Understand my point? You will get the Tyndall effect. you'll get to know what is Tyndall effect over it. Okay. So Tyndall effect, it's not a very big thing. Tyndall effect is just scattering of a beam of light. It's a scattering of a beam of light.
So what is light wavelength?
The wavelength of light is 450 nanometers. That's, I'm talking only about the visible light. It's 450 nanometer to 750 nanometer. So this is the wavelength of visible light, which we call wavelength. So violet has the wavelength 450 nanometer and red has the wavelength 750 nanometer. Okay. Now see what happens with this example. You will know what is Tyndall effect actually. So here as an example, we are considering our Earth and the Sun system. So as we know, our Earth is very small as compared with the Sun, and Sun is quite big. So the light of the Sun travels from Sun to the Earth. All of us know that the light of Sun travels from Sun to the Earth. Now from this Earth, we are able to see Sun. Okay. Now, what do you think about the path between them? If anyone from the space looks at it, so the path between Sun and Earth, what color? What should be the color of it? Will you observe the light coming from Sun to Earth or not?
No, sir,
No, sir.
because they are
Yes.
particles are not between Earth and Sun.
Yeah. Yeah. There are no particles present between the Sun and the Earth. Since there are no particles present between the Sun and Earth, so no scattering will take place, and hence the path of the light through which the Sun's light is traveling will not be visible. But the path of the Sun's light will not be visible to us on the Earth. Got it?
Yes, sir.
So now on the Earth, when the light reaches the Earth, our Earth has the atmosphere. So through the atmosphere, when light passes, now the particles which are present in the Earth's atmosphere, they scatter the beam of light, and hence the path of light starts becoming visible on the surface of Earth. And that too not everywhere. If you have the particle size greater than a few nanometers, then only the scattering takes place. Okay. So I think everyone has understood about the Tyndall effect. Okay. One more thing is there in this chapter relating to the all these activities only, that is Brownian motion. So maybe it may be somewhere in your book or may not be. I don't know. So what is Brownian motion?
So can you repeat?
Yes.
Sir, we don't know.
Anyone else who can tell Brownian motion? Advait? Advait?
Yes, sir. I don't know the answer.
Okay. Yukta,
Yes, sir.
do you know anything about Brownian motion?
No, sir.
So
So
see,
actually,
Brownian
this is
motion,
not
it is,
there in textbook.
it is, it is the random zigzag motion of particles of a solute. Okay, so what was actually Brownian motion? See, a scientist, he took a solution, or he took water in a container, and in that water, so he took some water in a beaker or a container, and in this he put few pollen grains on the surface. So he put a few pollen grains on the surface and started observing these pollen grains. So what he observes that none of the pollen grains are stationary. He observed it for a very long time. He observed the same thing even after, let's say, about 1 day, 2 days. So every day he was observing that the particles of these pollen grains, they are continuously moving in zigzag fashion. They are moving from here like this, and they are continuously moving. There is no change, and they are not having a fixed path. So this motion of the particles is called as the Brownian motion. Got it?
Sir, what are those particles?
Here in this case, he had taken
Yes,
pollen
sir.
grains. Okay.
So
He
can
had
you
taken
write?
pollen grains. Here. In this activity, the items taken are pollen grain. However, other particles also showed Brownian motion. Other particles, they also showed, if they were put on the surface, they also showed Brownian motion. So it shows that yes, the particles are in random motion. Got it? So these are the things we have studied in this chapter. In this chapter, we have studied solutions, suspension, and colloids. Then,
Sir, can we say that Brownian motion tells about the kinetic energy or the movement of particles between the molecules or atoms?
yes, yeah, it can tell about the kinetic energy of the particles. Got it?
Okay, sir.
So after the Brownian motion, we had a little bit about crystallization process. I think crystallization is there in this book. Just let me check it if
Sir,
it's there in
actually,
this.
in the book which I have, there are no crystallization or there is no topic about separation of mixtures.
Okay, so you can just leave out that. And then next is elements and compounds. So what are elements and compounds?
So next chapter.
In this chapter only, you have elements and compounds.
Yes, sir.
Okay. Okay. Are your bio classes running? Manisha is taking your bio classes?
No, sir. There are no
No.
biologicals.
Okay. So how many chapters have been completed in bio?
One,
So
sir.
my half chapter is completed.
Which one?
First chapter.
First chapter means cell you have completed, right?
No,
Yes,
sir.
sir.
I full half the chapter is completed.
Okay, only half. Okay. Only half the chapter, right?
Yes,
Yes,
sir.
till the scientists and cell organelles we completed.
Scientist and cell organelles.
Yes, sir.
Sir, first 2 pages or first 3 pages of the chapter.
Okay. So from the next class, we'll be starting with bio only. I'll just ask Manisha ma'am, she was saying. So I'll continue with that.
So will you teach bio?
Yeah, obviously the last year I was also taking bio, and this year since ma'am was there, so that's why I was not taking. I was taking other classes, right?
Okay, sir.
Actually, my subject is physics, so I take physics for higher classes, grade 11 and 12.
Sir, do you take for 10th chemistry and biology also?
Yeah, so last year I was taking all the three.
So for 11th and 12th, are there other teachers?
Yeah, there are other teachers also for 11th.
Okay, sir.
So for elements and compounds, let us see what are elements. Okay, so elements are the purest form of matter. Purest form of matter. That means they are made up of elements. They are made up of a single type of particles. So if I say an element oxygen, so oxygen element will be made up of single type of particles, which will be
So we can
similar
take
in all respects. They will be similar in all respects.
So
Similar
can
in
you
all.
give similar type of atoms?
Yeah, all the similar means same in the case of size and same in case of mass. So their size, mass, charge, everything is similar to each other. So that is why elements are the purest form of matter. Then compounds. What are compounds?
Chemical
Uh,
combination of
two or
elements.
more elements.
Chemical combination of.
Two or
Two or
more
more
elements are
elements.
these compounds.
Okay. So chemical compounds formed when two or more elements chemical compounds found when two or more elements combine in a fixed ratio. Fixed ratio by mass. Fixed ratio, or you can say. So in case of compounds, the ratio in which the elements you will find, the ratio will be fixed. But with the case of mixtures, the ratio is not fixed. The ratio can change. Also here, the chemical properties are enhanced. Chemical properties are changed of the combining particles. For example, suppose if you have carbon dioxide, so carbon dioxide is a compound, okay, and it consists of two types of particles. So which are the two types of particles that you will find in this?
Carbon
You
and
will find,
oxygen.
yeah, you will find carbon and oxygen. Okay. They both will be different from each other, but carbon will be similar. There will be different atoms of carbon and there will be different atoms of oxygen. And their ratio is always in the ratio 1:2. In carbon dioxide, you will always find carbon and oxygen in the ratio of 1:2. Got it?
So actually, I have a doubt about solutions.
Okay. So what's the doubt?
Sir, if we mix sugar and water, will the chemical composition change? Because the particles of sugar become attached to the particles of water.
Okay. But then they can be separated out by the physical methods. Okay. And also the properties of sugar are not changing. The properties of water is not changing. Got it? Since the properties of the combining particles are not changing, and it is possible to separate them by some physical processes.
Okay, sir.
So that is why that is a physical change and not a chemical change. Got it?
Okay,
So
sir.
I think everyone is clear with elements and compounds. Let's quickly do the
Yes, sir.
question answers from this, and then we'll move to the next one. From the next class, we'll be starting with bio. Okay. So which separation technique will you apply for the separation of the following? I think we can leave this since you do not have the methods of separation.
Yes, sir.
Okay. Or can you answer them? First one, sodium chloride from its solution in water. If you
Sir,
know,
so
just
can we use filtration?
no.
Sir, is it soluble?
Yeah, it is soluble. Sodium
Then
chloride
we
means
can use
common salt.
evaporation.
Your common salt has the chemical name sodium chloride.
Yes, sir.
So how will you separate it?
Sir,
Sir,
evaporation.
Evaporation. Very good. Who did answer? I think this was from
Jitendra,
the.
sir.
Okay, Jitendra. Very good. Be active. Okay, that's nice. So whenever you know the answer it. Then B, ammonium chloride from a mixture containing sodium chloride and ammonium chloride. How will you
The
separate out
sublimation.
Purification.
Sublimation.
sublimation? Correct answer is sublimation. And sublimation is the process by which the substance changes from solid state to gaseous state directly. So by the process of sublimation, I will be able to separate sodium chloride and ammonium chloride. Then small pieces of metal in the engine oil of a car.
Sir, evaporation. Filtration.
Evaporation, filtration. We'll use here filtration method to separate the mixture. Then different pigments from an extract of flower petals.
Sir, chromatography.
Yes, chromatography. Then fifth one is butter from curd.
Sir, centrifugation.
Centrifugation.
Centrifugation, okay. Oil from water.
Sir, separating
Also by filtration.
Separating funnel.
Yeah, by separating funnel, that is decantation. So decantation uses separating funnel. Then tea leaves from tea.
Filtration. Filter paper.
Filtration, okay. What wheat grains from husk?
Yes, sir.
Wheat grains from husk.
Winnowing.
Winnowing method. Fine mud particles suspended in water.
Subfiltration.
Sedimentation.
You will use sedimentation or you can also use filtration. Both the methods will be. But if the particles are fine, so we should go for sedimentation process. Okay, write the steps you would use for making tea. Okay, just leave that. Okay, here, Pragya tested the solubility of three different substances at different temperatures and collected the data as given below. The results are given in the following table as grams of substance dissolved in 100 grams of water to form a saturated solution. So, what we are looking for this is, see, this topic is a concentration of a solution, or we also call it, we'll also read it solubility. So, solubility is another topic. What do you mean by solubility of a substance?
So solubility is the amount of solute which can be dissolved in the solvent.
Yes, amount of solute that can be dissolved in a solvent. So, how much quantity of the solute can be dissolved in a solvent? That represents the solubility. So, generally for the reference, we take about 100 ml or you can say 1 liter. Then we have concentration of the solution. So, how do we measure the concentration of a solution?
So there are three types: mass by mass, mass by volume, volume by volume, in
Okay.
which
See,
we keep the amount of solute by the amount of solution,
okay.
whether it's
So,
mass or volume.
so you have a concentration of solution. In the case of concentration of solution, you have mass by mass method or you have volume by volume method,
So mass by volume also.
or the last one is mass by volume method. Okay. So mass by mass method, yeah, here the formula is mass of solute divided by mass of solution multiply 100. So this gives us mass by mass percentage of the solute. V by V or volume by volume. So when you are taking your solute in a liquid form, so we'll measure its volume. It's easy to measure its volume. So volume by volume form, we write it as volume of solute divided by volume of solution. Okay. The last one is mass by volume. So this is mass of solute divided by volume of the solution. Okay. And all multiplied by 100, that is your percentage. You get your solubility in terms of percentage. One more thing, we have learned about the saturated solutions. So what are saturated solutions? Yes, what are saturated solutions?
Solution in which no more solute can be dissolved.
Yeah. A saturated solution is a solution in which no more solute can be dissolved. A saturated solution. So saturated solution, it is the solution in which no more solute can be dissolved.
Sir, what are the class timings actually?
Yeah.
What are the class timings?
What has been?
So class timings.
Class timings are 7 to 8.
Okay, sir.
Okay. So I think you people are expecting that class is from 7 to 7:40 or 7:45.
Okay, sir.
Is that?
Actually, the Friday class also you did until 7:40 only.
Yeah. So at that day I was not feeling well, so that's why I ended at 7:40 only.
Oh, but we are having maths class just 40 minutes.
See, earlier the classes were for 40 minutes, and that were 4-day classes, right? You were having 4-day classes of 40 minutes each. So that made it about 160 minutes. And now you have 3 days classes with 60 minutes. Okay. Your all classes are for 60 minutes. So 3 days, that makes it 180 minutes. Got it?
Yes.
So that's why it has been, since I think what you're facing some issues, some people are facing issues at 5:30, joining at 5:30. So that's why the class timing was shifted to 7 and we have made it 7 to 8. Okay, so be patient. And if you feel boring, so is there anyone who can sing a song in their own language? You can sing a song, but in your own language, in your mother tongue. Okay, I think you should not be feeling bored. So just let me see. Sampath, where do you belong to? Sampath,
Yes, sir.
where do you belong to?
Sir, Andhra Pradesh,
Okay, so your mother tongue is
Telugu, sir.
Telugu. Okay. Advait, what about your mother tongue?
Sir, my mother tongue is Marathi.
Marathi. Okay, so where do you belong to?
From Maharashtra.
Okay, Maharashtra. So Maharashtra where?
Sir,
Okay, which city?
Pune.
Pune. Okay. Okay, so that's nice. So let's concentrate again. Yukta, which state do you belong and what's your mother tongue?
Sir, I'm from Telangana. My mother tongue is Telugu.
Telugu. Okay. So, but still your Telugu will be different from I think what Sampath is having.
Yes, sir.
Yeah. So there are little bit of variations which we call as the dialects, which make them as dialects of those regional languages. So see this question again. Pragya tested the solubility of 3 different substances at different temperature, collected the data as given below, and so your potassium nitrate, the solubility of potassium nitrate at 283 Kelvin is 21. The solubility at 293 is 32. So
Sir,
you can
actually, I
say,
have done.
yes,
Sir, means this 2132 are these the grams?
yeah, they are grams.
Means
21,
21 potassium nitrate 21 grams in 0 degrees Celsius
yeah,
or 10
21
degrees.
grams in 100 grams of water at 283 Kelvin. 283 Kelvin means 10 degrees
10
Celsius.
degrees Celsius. Yes.
So in degrees Celsius, this temperature is your 10 degrees Celsius. This temperature is 20. This is 30, I think
30. So 30 or
40.
40, 40.
40.
What is,
This is
and that is
40.
60.
This is 60. And this is
So 80.
80 degrees Celsius. So potassium nitrate, the solubility of potassium nitrate is 21, 32, 62, 106, and then 167. Sodium chloride is 36, 36, 36, 37, 37. So you can see the solubility of sodium chloride is almost not changing. Almost. It's not variable. Potassium chloride solubility is 35, 35, 40, 46, 54. And ammonium chloride, the solubility is 24 and then goes up to 66. So on the basis of this data, we will be having some questions. So what mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin? So you have to look at 313 Kelvin.
So it is
How
40.
how much? Yes. Who will answer? Sampath?
Yes, sir.
Yeah. So how many grams of potassium nitrate are required in 50 ml of water at 313 Kelvin?
Mm, sir, 50
Okay, do
grams
you
of,
want to see the complete question?
yes,
It's
sir.
here. Okay, two people have raised their hands. So here,
300
it's
watt.
100 grams of water are there, and in 100 grams of water at 313 Kelvin, you are able to dissolve
62 grams.
62 grams. Okay. Yeah, Jitendra, what's your answer?
Sir, 31 grams.
31 grams. Okay. So here
So,
answer is 31 gram. Yes.
Sir,
yes, sir.
sir, so the saturation level reduced by half to keep it the same level.
Yeah. So it is 31 grams.
So 31 grams of the solute can be dissolved in
Yes.
50
Since
grams of
62
water.
grams is, yeah, you are correct. Both of you answered correctly. The next one, Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Explain.
So,
So at 353 Kelvin, she is talking about potassium chloride. So see, for the
sir,
yes,
sir, actually, we will see the crystal settle down of potassium chloride because the solubility at the room temperature will be less than 350, 35.
yes. So at 333 Kelvin, you will have 55 grams being 46 gram potassium chloride being dissolved. And if she cools at room temperature, which is about 20 degree, so now only 35 gram can remain in the solution. So the remaining part, it will be or it will form the crystals and separate out from the water.
So, crystallization.
Yeah, crystallization process will occur. Okay, explain the following giving examples. Saturated solution.
So, we have to do the C and D part of the third question.
Yes, what happened?
So, we didn't do the C and D part of the third question.
Okay, C. Okay. C is find the solubility of each salt at 293 Kelvin. So all of you quickly find the solubility of each salt at 293 Kelvin. This is your 293 Kelvin at this temperature. You have to find the solubility of each salt.
So, done, sir.
Everyone has got the answer? All of you try to find out the solubility. So for the first, for the potassium chloride, the solubility will be 632 divided by 100 multiply by 100. Okay. So it's 32%. For sodium chloride, you will get 36%.
What is multiplied by 100?
So that you will get percentage. Even if you don't use percentage, you will
Sir,
get your answer.
actually, we told 32 by 100 into 100.
Okay. So you can just write 32 by 100. If you don't need the percentage solubility, so you'll just write 32 by 100. For the next one, it will be 36 by 100, 35 by 100, and 37 by 100. Or you can say the solubility is 32 grams per liter. Sorry, this
Per
is
100 grams of water.
yeah,
100
you have
grams. 1 by 10th of liter.
yeah. So you can write it as either as 320 gram per liter, 360 gram per liter, 350 gram per liter, or 370 gram per liter. All of them are. Then the last one, I think we are on the last question. What is the effect of change of temperature on the solubility of salt?
Sir, actually, there is negligible effect. There is very less effect of the solubility of salt depending on the temperature.
There is very less.
Yes, sir. 1 degree Celsius means 1% was only increased.
Okay.
So can you scroll up?
Okay. Okay, we'll leave the fourth one as we have already done. We'll do question 5. Classify the following. Classify each of the following as homogeneous or heterogeneous mixtures. What are homogeneous mixtures?
So they have uniform composition.
They have uniform composition. And heterogeneous mixtures?
The non-uniform composition.
Yeah, heterogeneous mixtures have non-uniform composition. Very good. So homogeneous and heterogeneous. Then soda water. What about soda water? Is it homogeneous or heterogeneous?
Sir, homogeneous.
Homogeneous. And wood,
Sir, heterogeneous.
heterogeneous. Okay. Air,
Sir, homogeneous.
Heterogeneous, sir.
Heterogeneous.
air is
Yes.
a heterogeneous mixture.
Yeah.
Okay. It consists of dust, sand, other particles are also there, which makes it a non-uniform composition. Okay.
Okay, sir.
Soil,
Sir, heterogeneous.
Heterogeneous, sir.
heterogeneous. Vinegar,
Homogeneous.
Homogeneous.
homogeneous. Filtered tea,
Homogeneous.
Homogeneous.
homogeneous. Okay. The last question. How would you confirm that a colorless liquid given to you is pure water?
Sir, sir, actually, it's not given in the textbook.
Okay, everything is not given. Use your brains. Use your brains and see how you can tell that the liquid given to you is pure water. Okay, pure water will show you the characteristics of a solution.
Whereby
No.
doing Tyndall effect.
Yeah, no, the water will not show the Tyndall effect.
Sir,
Yes,
or tested by the melting point or the boiling point.
Water
so we
will
can
not show.
test the
Yeah,
boiling
what
or
happened?
freezing point.
Sir, we can test its boiling point and melting point. If it's pure, it will be this constant.
Okay.
So
So
we can evaporate.
Okay. You can either evaporate a little bit of it and see if there are any remains. First of
So
all,
we
we'll
can
look.
try to do sedimentation.
Okay, first of all, we will check for the sedimentation. If there are no particles seen, we will look for colloidal. That is, we will use Tyndall effect. If it doesn't show Tyndall effect, then we are almost sure that it is going to be pure water only. Now we just need to check for the solubility. Check for whether it's a solution or not. Okay. So to check whether it's a solution or not, we can take a small part of it and evaporate and check. That's the only method. Or you can also check their electrical conductivity.
Yes, sir.
Okay. Okay. So bye all of you. See you
So
again.
basically, how to do the electrical conductivity?
Electrical conductivity as a pure water is a bad conductor.
No,
Okay. Or
sir.
poor
How
conductor.
can we separate a hydrogen and oxygen from the water? How can
Yeah.
we?
If you want to separate it by the electrical method, then you need to make the water impure first.
Okay, sir. Then afterwards.
Okay. So first you need to make it impure, then you can. Okay. So bye all of you.
Bye, sir.
Thank
Thanks.
you, sir.
Okay. Bye.